This is my original egg cart design. The end product ended up looking a little different than this, but it's still a similar concept, and these are the materials I used, a little bit more than what's here, but it's just basically the materials I used. So over the next minute or so, you're going to see me building the car and the frame and everything that goes into it, and it's going to look a little weird because you're going to see me taking off wheels and putting them back and putting on cotton and putting on rubber bands, and that is to keep the car and keep the egg safe, mainly keep the car from falling apart. So you can see that I'm putting together the frame. Originally it was going to have a bevel at the front, but I changed my mind because I didn't have enough sticks and it wouldn't fit properly. And then you're going to see me attaching like the rubber bands to hold the seat belt and the egg in place, and those worked really well in the end because they held the egg back from the collisions. And you're going to see in a little bit that I'm going to add a bumper to it as well, and that bumper created a sort of elastic collision, but wasn't a total elastic collision because it wasn't perfect because, you know, the ramp that we used wasn't in a vacuum, but it created a semi-elastic collision that really protected the egg. And the cotton at the front, and you're seeing me fix the wheels, and the cotton at the front and the back of the egg and on the bottom as well cushioned the egg and absorbed a lot of the impact and the change of momentum, which was the impulse, which is what we're really protecting the egg from because the change of momentum is bad. And then I put a topper on just in case it flipped over, which it didn't. And then this is me testing it, and it survived. And coming up next is the actual tests.
You go?
Yeah.
You gotta show us that it survived.
I think it survived. Okay. Bum, bum, bum. There's no leaking.
No leaking, no cracking,
Nothing.
no dying.
Nothing.
I love that it has horns on top. Okay.
Thank you. I brought crazy food with me because it shifted a little bit, but it's not broken, it's not leaking.
Okay. Good.
I'm gonna reattach. So we'll survive this one. I have no idea if it will, but it should get better. I can see some of the egg died. It survived!
Yay! Good job.
So right here, you're going to see 3 of the questions I had to answer, talking about will the solution I made previously protect the egg. This is before I did the trials, by the way. And I said the cotton and the rubber bands would protect it. How do I know? That reducing impulse is by extending contact time. The rubber bands hold the egg in place, and the cotton extends it because cotton is squishy and absorbs things. And what changes? Need to remeasure some things, which I did. Figure out how to put cotton in it without falling out, which I did. And be sure to measure. And I added the counterweight, like I said. I didn't mention that before, but I added a counterweight because the egg was heavier than I thought it'd be. And like I said, the restraint system worked as expected because I tested on the pizza boxes, on the stairs like you saw earlier, and I wasn't able to get the exact things, but it was right, and it was protected the egg from the impulse, and I was glad that happened because it worked as expected. So you can see the mass of my cart with the egg, which was about 0.1 kilograms, which isn't a lot, but when you think about for an egg, it's kind of a lot. And then I put the mass aside for a second to focus on the velocities, which is the distance and the time. The distance for each of 3 trials, you can see sort of to the right middle, was about 3 meters, and then divided by each of the times for the trials gave me different velocities, and the greatest velocity was the 3rd one, which is also the highest, which was expected because of gravity. And I got about 2 meters per second for that. And then I used the momentum to get the greatest momentum, and I had to use the mass for that, finally. So momentum is mass times velocity, so I multiplied that, and the momentum I got for the last trial was about 0.3 kilograms per meters per second. Impulse was the hardest to get because I had to get the time, which is on left, and the time was really hard just to see the impact from when it hit and then when it stopped. It was about less than like 0.2 seconds, and then I had to get the velocity of the original time, and I got about 1.8 meters per second squared, and then I had to use that to get the force, which ended up being like 0.2 newtons, and then the impulse would be really, really tiny, which was like 0.04 newtons per second. And so that was just like the whole change in the momentum and stuff, but it was just really weird to see how small the time of the momentum was, and then multiplying that by the force to give such a small number. And then the paragraph at the bottom was just basically re-explaining everything I just said in CER form. The impulse was for the 3rd trial as well as the velocity and momentum, so it was the same trial, just trial 3.